In the following examples, we are going to be working with polynomials. Polynomials are algebraic expressions, like these, that have letters, or variables, and constants in front of those variables. In particular, we're going to classify them, add them, subtract them, and multiply them. Let's begin by naming each of these polynomials by their degree. Now, by degree, we're talking about their highest power. In number 1, we notice that the highest power is 4. So we're going to call this a fourth degree polynomial. Easy enough. Number 2, instead of calling this a third degree polynomial, we actually call this a cubic. So it does get a little more complicated. And on number 3, we have a highest power of 2. So instead of calling this a second degree, we have another special name for this. This is called a quadratic. Over here, we understand that the exponent is 1. So the highest power is 1. And we have another special name for this type of polynomial. These are called linear. Now, when we don't have any variables, we describe this as constant. Now let's name some polynomials by the number of terms. So this time we'll be counting how many terms there are. So number 6, we have 1, 2, 3 terms. So we call this polynomial a trinomial. Tri means 3, like a tricycle has 3 wheels. Number 7, we have 1, 2 terms. And so we call this a binomial. And when we have a polynomial that has just one term, we call it a monomial. Right, at number 9, we have two polynomials that are being added. Now, the main idea when we're trying to simplify in a situation like this is to combine like terms. So when we're adding or subtracting two polynomials, we are going to combine like terms. So one easy way to arrange our work for a situation like this is to take this second polynomial and put it underneath the first one, and we're going to line up the like terms. So I'll put the 2v cubed underneath the other expression to the third power, and I'll put the 7v squared underneath the other v squareds, and we're adding these. So I'll start with my v cubed. We start with 3v cubed, and we add 2 more v cubes. So now we have 5v cubed. Here we have 3 negative v squared, but we're adding 7 positive v squareds. So now we have 4v squared, because 7 minus 3 equals 4. And then this minus 4 just tags along. And there are no more like terms to combine, so we're done. On number 10, we are subtracting two polynomials. To avoid making mistakes with our negative signs, let's go ahead and change this to an adding problem. But when we do that, we need to change both the signs inside the parentheses, because we're subtracting everything in here. So we're going to add the opposite and the opposite. So the 5a cubed is negative, and so is the 3. Right, I'm going to line up my third powers. And the negative 3 will go underneath the 2. And remember, we switched this to an adding problem. We understand there's a 1 in front of the a cubed. So I start with 1a cubed and subtract 5a cubes. So that leaves me with 4 negative a cubes. Because negative 5 plus 1 equals negative 4. The 3a's just tag along. And 2 minus 3 equals negative 1, so I can write minus 1. There are no more like terms to combine, so we are done. Now let's look at multiplication. With a multiplication like the one in number 11, all we need to do is distribute the 6x. So we're going to multiply the 6x by each of the three terms inside the parentheses. So I'll write this out the long way. That means we have 6x times 6x squared. Now our next operation is subtraction, so why don't I keep that? Minus 6x times 5x plus 6x times 2. Let's work out the math here. We have 6 times 6 and x times x squared. We understand there's a 1 there. So x times x squared is x to the third power. And here we have 6 times 5 and x times x. So that's 30x squared. And then 6x times 2, well, that's just 12x. Notice we do not have any like terms here, so we are done. Okay, number 12, you've seen problems like these before. We are multiplying two binomials. And some people like to multiply these with a box diagram. But we can also just use the distributor property. So I'm going to distribute the negative 6x and multiply it by both terms in the other parentheses. And then I'm going to distribute the 5 and multiply it by both terms in the other parentheses. So I'm going to have 4 little multiplication problems here. So I'll start with negative 6x times negative 2x. Then I'm going to multiply negative 6x times negative 8. Then I'm going to multiply 5 times negative 2x and 5 times negative 8. Let's work out the multiplication here. Negative 6 times negative 2 is 12, and x times x is x squared. Here we have negative 6 times negative 8 times x, so that'll be positive 48x, because negative times negative is positive. We have 5 times negative 2. That'll be negative 10x. And 5 times negative 8. Looking through our results, we see that we have some like terms, the 48x and the negative 10x. Let's combine those like terms and rewrite our results. So we have the 12x squareds coming along. 48x minus 10x is 38x minus 40. Now we have no more like terms, so we are done with our multiplication problem. Now here we have a trinomial being multiplied by a binomial. Now we could think of it just like we were before with the distributor property, but perhaps a better way to organize our work is to put this binomial underneath the trinomial and multiply that way. So I'll put negative 5p minus 2 underneath the original trinomial, and we are multiplying. So now I'm going to take this negative 2 and multiply it by each of the three terms in the trinomial. So negative 2 times negative 3 is positive 6. Negative 2 times 1p is negative 2p. And negative 2 times 3p squared is negative 6p squared. So really all I did there is distribute the negative 2. I just have it organized a little differently. Well, now I also need to distribute the negative 5p. And when I do that, I'm going to line up my like terms with these. So negative 5p times negative 3, that'll be positive 15p. I'll line those up with the other p's. Negative 5p times p would be negative 5p squared. I'll line those up with the other p squareds. And negative 5p times 3p squared will be negative 15p cubed. And now, just like when we're multiplying with numbers, we're going to just combine our like terms here for these two lines. So I have plus 6, that just tags along here. This is a total of 13 p's here. Here we have negative 11p squared. And the negative 15p cubed, that just tags along here. Notice we do not have any like terms that need combining, so we are done. Let's try one more of those. Now, this way of arranging our work is just a way to keep track of our distributor property. So I'm going to write 5b minus 5 underneath here. I'm going to distribute the negative 5 into the original trinomials. That'll be negative 10, and then negative 10b, and then negative 10b squared. So I just multiplied each of these terms by negative 5. Now I'm going to multiply those same three terms by 5b. So 5b times 2, that'll be positive 10b. 5b times 2b, 10b squared. 5b times 2b squared be 10b cubed. Now we need to add these two lines together, or combine like terms is really what we're doing here. So the negative 10 will tag along. These b's cancel out, because negative 10b plus positive 10b leaves us with no b's. Same thing here. These negative b squareds cancel out these positive b squareds, leaving us with no more b squareds. And so the 10b cubed, I'll just bring that down and put it close to the negative 10. That's it for our notes about classifying, adding, subtracting, and multiplying polynomials. This is Mr. Ela, signing off.